So prove. Or disprove, more like. So here, is a universal statement, right? And so we disprove a universal statement by counterexample. So I'm going to say disproof by counterexample. And what do we want A and B to be in our counterexample? I said 3 and -3, but what do you guys want? This is not my proof, it's our proof. So what do you guys want? $42. All right, almost the answer like the universe and everything. Also, Jack Robinson's number. That's great. But anyway, so disproof by counterexample. Let A equal 42 and B equal -42. We could have done the other way around with B equal -42, A equal 42 does not matter. What's like after we pick out out the things we use in a counterexample, what's the first thing we do in every counterexample proof?
Do we state the negation of the statement we're trying to disprove formally, or?
We don't really need to. You could if you want to help you out. And so in our case, the negation is that there exists an A and Z, and there exists a B and Z such that A divides B and B divides A, and A is unequal B. Or A is not equal B, and or A equals B, and A does not divide B, or B does not divide A. If you work it out, this is the negation of this. The reason being, well, this is the negation of this guy here, and this is the negation of this guy here. And the point is that since it's an if and only if, there's two ways it can fail. Either the first way doesn't work or the second way doesn't work. And so this is saying the first way doesn't work, or this is the second way doesn't work. If either one doesn't work, if and only if it fails. But
okay, then do we verify the domain?
Exactly. First thing to do is verify A and B are all what we care about. And what that means is that in the domain, and specifically for universal conditionals, we care that the hypothesis is true. So we care that since we're disproving this side, we show that A and B are integers, and this hypothesis happens. So note 42 and -42 in Z, and actually, just to avoid run-on sentences, further note B, which equals -42, equals -1 times 42, which equals -1 times A. So, since -1 is in Z, A divides B. Right? All we did there is we proved that A divides B. we proved that 42 divides negative 42 by showing that there's that negative 42 is in fact an integer multiple of 42. Also, a equals 42, which equals negative 1 times negative 42, which equals negative 1 times b. So since negative 1 is in z, b divides a. So our hypothesis is true as required. You don't necessarily need to write this part, although, you know, for proofs, it's always nice to kind of walk your reader through what you're talking about, right? Because proofs are kind of meant to be read. And so it's always nice to say, like, we're doing this now because of this. So our hypothesis is true as required because we're doing the counterexample thing. So far, all we've shown is that we have picked an A and B, where A divides B and B divides A. That's all we've shown so far. But, well, I'll say, however, now the counterexample part for this is really easy. However, 42 does not equal negative 42. We're allowed to know that integers aren't equal to each other, right? That's the thing we're allowed to assume. However, 42 is not equal to 42. So the conclusion is false. Therefore, there exists integer a and b, mainly 42 and negative 42, with a divide b and b divide a, but a does not equal b, hence our claim is false. Any questions? Yeah, I think it's pretty simple, right? I mean, this is like, well, once again, counterexamples are in a certain sense, they're definitely, the proof part is easier. Like getting to them might be harder because you have to think of maybe a kind of weird example, but actual proving is easy. You just say, here's A and B, doesn't work, go home. Well, everybody, we're done. But yeah, so, you good?